Hey there, welcome to our video about the cool patterns we find in nature and in the world.
Welcome to the world of natural patterns.
Symmetry pattern are a design or pattern that is the same on both halves when folded. Symmetrical patterns can have one line of symmetry or more. These lines of symmetry may be vertical, horizontal, or diagonal. This is an example of an asymmetrical pattern with one line of symmetry. 3 types of symmetry.
First is reflection symmetry. It is also known as bilateral symmetry. It is a mirror effect or when one object is reflected or flipped across a plane to create an image of itself. So here are the examples. In nature, ferns shows reflection symmetry because if you draw a line down to the center, each side looks like a mirror image. In man-made, like sunglasses, have reflection symmetry because the lenses are mirrored on both sides.
Next, reflection symmetry. Reflection symmetry is also known as line symmetry or mirror symmetry. It states that if there exists at least one line that divides a figure into two halves such that one half is the mirror image of the other half. An example in nature is the way petals of a flower spiral around its center, forming a rotational pattern. In man-made objects, a wheel turns around its axle, exhibiting the rotational pattern as it repeats its position relative to the ground.
Next is translation symmetry. Translation symmetry is when something has undergone a movement, a shift or a slide in a specified distance without any rotation or reflection. Here are the examples. In nature, you can see this with the thorns on a cactus, and in man-made, like tiles and floor, you can observe translation pattern.
Next is a spiral pattern. A spiral is a curve which emanates from a point, moving further away as it revolves around the point. And the example of spiral patterns in nature is the seashells, and the man-made pattern as the bygone cattle product.
Is meanders. Meanders is one which refers to a winding curve or a bend in a river. So here are the examples. In nature, we have rivers. Rivers often form meanders as they flow, bending back and forth over the time. Similarly, in man-made, we have infrastructures like roads. You can see meanders patterns in winding or curved roads that follow the landscape contours.
Next pattern is a wave. A wave is a physical phenomenon characterized by its frequency, wavelength, and amplitude. In general, waves transfer energy from one location to another, in which case they have a velocity. The example of wave pattern in nature is the sea waves, or a classic example where energy travels through water, causing the surface to rise and fall. In man-made structures, like a roof, waves could occur in a form of vibration or ripples, caused by wind or other forces, creating patterns of movement or deformation. A bubble is a substance made by trapping air or gas bubbles inside a solid or liquid. In nature, the example of bubble pattern is the sea foam exhibits this pattern as waves churn water and create bubbles. Similarly, in man-made products like detergent soap, when mixed with water, the soap molecules form a bubbles pattern due to surface tension, trapping air and creating bubbles. Next is the tessellation pattern. A tessellation is telling that uses shapes to cover a surface with no gaps or overlaps. In nature, sea stones often tessellate when they wash up on a beach, forming a pattern like puzzle pieces. In art, a common example is a tiling in Islamic geometric art, where shapes like triangles, squares, hexagons fit together to create intricate designs without any gaps.
Next, fracture occurs when the applied stress is sufficient to break the atomic bonds of the solid. a separation of an object into two or more pieces under stress. In nature, you can see in these branching patterns of trees where branches split off from the main trunk. In man-made objects like color pens, if you break one open, you'll see a similar pattern where the material fractures into smaller pieces or branches. Crack is a line on a surface of something along which it has split with breaking into separate parts.
In nature, crack pattern like on tree bark, cracks form due to growth and environmental factors, creating unique patterns. Similarly, on man-made surfaces like floors, cracks develop due to stress and settling, often forming distinctive shapes and lines. These patterns are fascinating examples of how mathematical principles can be observed in the physical world.
Next is fractal. A fractal is a never-ending pattern. Fractals are infinitely complex patterns that are self-similar across different scales. They are created by repeating a simple process over and over in an ongoing feedback loop. In nature, we have the branches of trees. It is a fractal pattern because smaller branches look like miniature versions of larger ones. Similarly, a motherboard has a fractal pattern because if you zoom in on a section, you'll see similar structures repeating throughout the whole board.
Stripes are made by series of bands or strips, often of the same width and color along the length.
A spots pattern refers to the visual arrangement and distribution of spots on an animal or object.
These are the examples. In nature, a cat's fur can have a stripes pattern. And in man-made items like a t-shirts, stripes are created by waving or printing lines or different colors or weight.
In nature, think of a goat's coat, where spots or patches of fur are arranged in a consistent patterns across its body. In man-made objects like pajamas, you might see a spots pattern in the form of polka dots.
Lastly is the affine transformation. Affine transformation is a linear mapping method that preserves points, straight lines, and planes. The processes involved in affine transformations are rotation, reflection, and scale. In nature, we have cactus. As it grows, its branches might stretch, rotate, or even skew, but the overall structure remains similar. In man-made, objects like a motherboard, components are placed and connected in specific patterns, but the motherboard itself can be scaled, rotated, or skewed to fit into different devices while maintaining its functionality.